Hello guys, welcome back. In this video, let us understood and let us analyze the performance of these two processing units, that is CPU as well as GPU, by taking some data and processing that data. If you are implementing any processing, let's say if you are going to create a model or any ML based or generative AI based model, during that time there is a huge amount of processing is required. So during that time, what is the best fit for our requirement? Which work fast? Which processing unit's performance is good? So that we will understood right now in this video. To understood which is working, which processing unit is working faster, we are calculating the time between the process. We are taking a sample data, like we are taking a matrix data, and we are performing matrix multiplication. Then before matrix multiplication, we are taking the timestamp, and we are considering the timestamp after multiplication as well. Then we are considering the difference between the timestamps. Then we are predicting TPU, how much time it is taking, and how much time this GPU is taking. So based on that, we are predicting or we are plotting a graph to analyze the performance of these two different processing units. For this analysis, currently I have already created an EC2 instance with the instance type. You can observe here the instance type, that is P2X large. If we search for P2, that is a P2X large in Google, then it will show you the EC2 P2 instances. Now I am just opening this P2 instance family of EC2, and there I am checking how much GPU is allocated to P2X large. That is only one GPU is allocated and 4 CPUs, virtual CPUs are allocated. Now I want to use this. I want to use the instance that is created by using this instance type to understand how the performance of the one GPU or and how the performance of 4 CPUs by providing matrix multiplication. Now I want to connect to this instance. So for this, I'm just clicking on connect. Yeah. Now here it provides me an interface to connect. Directly, I'm connecting with this EC2 instance connect. After scrolling it up, now you can observe below, that is here, I have directly connect option. Now I want to use it to connect to this. Now I'm just clicking on connect, so that within few seconds, now my connection is established. Right now you can observe my connection is established. I have already installed a Jupyter notebook in this. Now I want to connect to that Jupyter notebook from this EC2 instance. And first I want to run that. Even though this terminal got stopped, or you can say even though this terminal is disconnected, I want to connect to that EC2 instance. That is my Jupyter notebook. I want to connect to my Jupyter notebook. So whenever a request will be sent to this, I want to send the request directly to the Jupyter notebook, and there I want to connect and I want to perform some operations on it. So how can you able to forward that connection from whatever the connection that is coming to this to there? So in order to forward your network connection to any local host, first you need to provide this key.pm file. So how you can able to connect to this instance? By using SSH connection only, right? Yes. So by using SSH connection, we can able to connect to any instance. And while connecting, we need to provide a PEM file, that is we provided here. Since it's a Linux machine, we provided pm.pm. If it is a Windows machine, then we'll provide .pp. .ppk we need to provide if it's a if this EC2 instance is a Windows EC2 instance. Now, to which connection you want to connect? As a what user you want to connect? By using a Ubuntu user to my local host, I want to connect. So during that time, each and every time, I want to forward my network connectivity to 0.0.0.0. So nothing but a local host colon to where I want to move, to where I want to forward my request is 800. So to this port I want to forward my request. The general server or the general port number of any server will be look like 127.0.0.1, and the general port that is used is 8888. Now so whenever any request coming to this, or whenever any request coming to this host is forwarded to this location, now I'm just clicking on enter, so that this forwarding connection will be established. So I think I did some mistake somewhere. Okay, SSH. It's not SSH, it's SSH connection. So we need to correct and provide it. Yeah, it is asking us to provide that forwarding, can we provide that forwarding facility? Now I entered S and I just clicked enter. Okay, now so whenever any request come to this port, that is forwarded to this local host. Now, so first what I want to set up a notebook, right? I want to set up a Jupyter notebook. Jupyter notebook. I've already installed Jupyter notebook in it. Now I want to set up that Jupyter notebook to connect to that. So even though this server is not connected, I want to connect to that Jupyter notebook. So like that, I want to provide a command that is no HUP, that is no hang up, no hang up. This Jupyter notebook. I'm just clicking on enter. You can see no hang up dot output file is generated. Now I want to tail this file to check the connectivity, whether this Jupyter notebook got started or not. So tail forcefully this no hang up dot output file. Wait for a moment. I think it's take 3 minutes. Then it will show you that, yeah, you can see now it is enabled. NB present HTML is enabled, and this platform related library is also enabled. Now our Jupyter notebook is running in this location. Now I'm just copying this. Now I'm connecting to this. I'm connecting to some local host. Now I have just opened the Chrome. Then now I'm pasting this URL, and here in the port number I'm providing 8000, and at the local host I want to provide my instance related URL. You can observe this is my instance and that public IP address is this. I just copied. Now I'm opening my browser, and there you can see I'm providing here that location or that IP address. Now I'm just clicking on enter. You can see my Jupyter notebook got connected, right? Yes, my Jupyter notebook got connected. Now I'm just creating one more notebook. So I'm just clicking on new, and I'm choosing this Conda TensorFlow P36, and here I'm pasting my code. So don't worry, I'll explain you this code. This code mainly contains 3 functions. Basically, our workflow starts at this experiment function, and here at the initial level we imported all the required dependencies libraries. And so whenever this code got executed, first this function will be started, and in this function we are taking a list of 2 devices, that is one is GPU and one is CPU. And each and every time, so first we are taking this GPU device and identifying how much time it take and what is the for what type of size. Like if the matrix size is 100 cross 100, then how much time this device is taking, how much time this device is taking. So that data we are storing in these 2 variables. By using this benchmark function, we are actually identifying how much time this GPU is taking with 100 cross 100 matrix, 200 cross 200 matrix, like that up to 7000 cross 7000 size matrix also. We calculated the matrix multiplication, and we are identifying the times and sizes we are storing in this. So don't worry, while showing this benchmark code, I'll show you that as well. Then after getting how much time and size these devices are taking, we are passing those devices as well as sizes, that is the matrix sizes, and how much time those matrices will take to perform that matrix multiplication. That also we are passing to this function, and then we are plotting the result here. Okay, so that's what we are doing here. Now let's understand in this benchmark how the code will be. In this benchmark, you can see I'm just passing the devices. One is CPU and another one is GPU. First, I just created a dictionary with the devices, like the output, or this will store like, so within this dictionary, it will store first CPU related data, then GPU related data also it will store as an empty list at first. So here also it will store an empty list. So for that's why I written this. Each device, for each device, the device contains CPU as well as the GPU. So first CPU will came, and like that this will be created. Then GPU will came, then this will be created. Now this represents the size range. By using this range function, we are starting from 100 size matrix to 7000 size matrix, and each and every time we are increasing the step by how much? 500. So first 100 size matrix will be taken, then 100 plus 500, how much? 600. So 600 size will be taken. So like that 100 comma 600 comma, like the end matrix or the end list will be 100 comma 600 comma, and so on up to less than 7000. Up to less than 7000 size, the matrix sizes will be taken as a list and stored in the sizes. Each and every time we are taking one size, and we are printing the sizes like 100 into 100 size matrix product like this we are printing, and we are taking each and every device. First we are taking the CPU, then we need to calculate the matrix multiplication, and we need to store the device times, right? Yes. So first we are creating the matrix. Then what we are doing is, here you can see we are creating two matrices, matrix 1, matrix 2, and we are defining the matrix multiplication is matrix multiplication of this matrix 1 matrix 2 by using this tensor flow. This TF represents tensor flow. We are performing this matrix multiplication. So then after, so each and every time, so first CPU will be taken and stored in this device. During that time, the starting time will be taken, and during the session is running, we are performing this matrix multiplication, and we are identifying how much time it is taken for matrix multiplication, and we are just printing that device with how much amount of time it is taken, and we are even storing the data in this times variable to that particular device. You can see times variable of that particular device dot append of this. That means in this list, first time what happens, this 100 size matrix related time will be stored. So then after, at first time that will be stored and the time also printed. In the second iteration, what happens, in this for loop, in the first iteration the CPU related result will be stored, then in second iteration the GPU related result also stored for first value of this outer for loop, that is for 100. Then after 600 will be came to the size, then for that 600 matrix 1 and matrix 2 will be created, then matrix multiplication function is again defined. So for the first time, for the CPU the value will be calculated and stored, then GPU value also calculated and stored. So like that we are calculating these many matrix related multiplication result, and we are returning the times as well as the sizes of our matrix. So for these sizes, that GPU as well as CPU will taking this much of time. So then after, we are providing the devices, sizes as well as the times. Devices represents CPU, GPU, sizes represents matrix sizes, times represents how much time that CPU or GPU is taking, and we are calling this plot results. In this plot results, you can observe we are taking the device and we are taking the size and times, and simply we are just plotting the data. So by using this legend function, we are passing the devices and we are plotting the data in 2x1 plot, and we are even marking the labels like which device is related to which color. Now yes, I want to just run this, so that's why I'm just selecting the cell and just clicking on run. It just take since this is a matrix multiplication, it might take a few seconds, and it will show you the result related matrix multiplication. First it will print, during this step it will print the size of the matrix as well as how much time the CPU and GPU will be taken. Then during this stage it will show you the plot. Let us observe and analyze how much time CPU is taking and how much time GPU is taking, like what performance, how much speed these processing units are performing the task. Based on the speed, we'll identify the performance and we'll analyze the performance. Now you can see 100 by 100 matrix is taken. Now CPU related result as well as GPU related results also shown to us. That is, this benchmark part is just now running. During this time, we can even observe how much CPU is taken from our instance. I'm just clicking on Control C, and I'm using the command, that is nvidia-smi. This you can use it to identify how much amount of GPU is taking. That related data you can able to observe here. Since we want live data, so that's why we're using this watch-n1 nvidia-smi, and now you can see it will show you the continuous data. Now you can see 37% of CPU is used. Like that, the GPU utilization will be fluctuate. You can see 67% of GPU is used. So like that, the GPU is also fluctuated. First it will just taken 37%, and next it was just taken 67. Now it was reduced, that is 13%. It also show you how much amount of memory is it taken. In this way you can able to observe how much GPU is taking. Only 0% is taking, right? Yes, only 0% is taking right now. And here if you observe the matrix multiplications, yeah, it's done. Graph also will get. Now let's also observe the thing, that is how much CPU is utilizing. That also let us observe. Now I'm just clicking on Control C so that this process will be stopped. Now I want to see the performance, or I want to see the CPU utilization. So whenever that code is running, I want to see the CPU utilization as well. So that's why I am using this top P to understand the processes which are running based on the given data. The data is so based on Python. So whatever the files are there, those related data I want to identify, process which are running. To get all the data, pgrep. So this command you can use. So first it will get all the process which are run with this name, and so then it will show you all those process. Now I'm just clicking on enter. I think we need to update this command. Now I'm just rewriting the same command and just clicking on enter. Unknown option 5. Okay. Okay, I think I'm getting some errors. So let's analyze the performance directly from here. I'm open to that Jupyter notebook. Here, if you observe, like 100 cross 100 matrix, GPU is taking almost 63 seconds, whereas CPU is just taking less than 1 second. That is just taking 33 milliseconds, right? Yes. So then 660 GPU is taking very less, that is 0.02 milliseconds, whereas CPU is taking larger than this, right? Yes. So whereas coming to 1100 cross 1100, the CPU is taking a bit more, whereas the GPU is taking a bit less than previous. So whenever, if you observe, if we are moving above, like the matrix size is getting increasing, if we observe, only at the starting time GPU is taking a lot of time, then after whole processing, GPU is taking very less amount of time. Even let's see the end, that is 6600 is the matrix size. Like that, we have multiplied two matrices with 6600. What happens? GPU is taking less than 1 second, that is it is taking just 35 milliseconds. That is this much fast this GPU is running. Whereas coming to the CPU, even though this instance type is having 4 virtual CPUs, this took around 14 seconds if we are providing a large amount of data related compute. Like now we considered matrix multiplication. Whereas for small amount of size of matrix multiplication, CPU is performing fastly. Coming to large, what happens? The performance got reduced. You can see the blue color line graph represents GPU related processing, whereas this orange color represents CPU related processing. Now initially it is taking me a large amount of time, whereas after that at the end it is taking, that is GPU is taking very less amount of time, right? Yes. If we consider the CPU, this is just one GPU because we provided M5X large, so that's why it is providing only one GPU and four CPUs, four virtual CPUs. That one GPU is performing very faster and the performance matrix will be very high. Whereas coming to this CPU, you can see whenever the size of the matrix is going on increasing, it is consuming a large amount of time. You can see the graph is increased, whereas the GPU, the graph is slightly increased, but almost it's the same. Almost it is less than, GPU is taking less than 1 millisecond, right? Yes. Only during starting of the GPU it was taking time. After that it is not taking much time, right? Yes. Coming to GPU speed up, you can see this is how the GPU speed up related to matrix size. So like this, the GPU as well as CPU performance analysis. If we compare the performance analysis between one GPU and four virtual CPUs, GPU is performing extraordinarily fast while computing the results compared to this CPU, four CPUs, four virtual CPUs. One GPU is working faster compared to four virtual CPUs. So this is all about CPU versus GPU performance analysis. I hope you understood with good knowledge. I hope you understood this concepts with good knowledge, and you also understood the hands-on implementation in real time, how the performance will be. That you understood, and the graphs also understood. So from this, I can say that this video is useful. I hope this video is useful. If you feel this video is useful, then please like, share, subscribe, and hit the bell icon to get the latest updates. Thanks for watching. I can see you back in the next video with another interesting topic. Until then, bye.